Okay, let's go back here. I wanted to restart this. Go back to operating systems, current. Okay, work group operating systems. We might also, let's just go ahead and edit that as network operating systems as well. We see both. And I will just change that so we can look at it. There we go. Work group and network operating systems. That network operating system, or NOS, is typically what you would see in a local area network, a LAN. Now, and that would be a good example is Helena College. So we have several servers that are set up in such a way, a primary domain controller, secondary domain controllers, or backup domain controllers that actually handle the authentication of the network when you log on, that it authenticates you as a user. It handles email, it handles your Y drive with all the file management services, and then all of those things that you see and do at Helena College. Now, typically you see Windows Server 2008 or 2012, which is replacing 2008, as that network operating system environment or server platform. And that platform is a combination of hardware and software. So, a Dell box, an Intel box with Server 2008 as a platform. Now, you also see NetWare, Novell NetWare, as a network operating system. Not so much anymore. It used to be pretty big. It used to be bigger than Microsoft, the Microsoft system, but not anymore. Now, you also see Unix can function as a network operating system. The Mac OS can function as an operating system, but you don't hardly see, I can't remember seeing a single installation of your Mac OS X server in any local area network. Oh gosh, there we go, enterprise operating systems. So in that area, we're talking about those big boxes, those mainframe systems, those blade servers that are scalable, that you can add memory into and microprocessors into or processors into to expand their ability. These are like the IBMs of the world, the Ciscos of the world. All of those big organizations will use enterprise operating systems. Utility programs are those programs that help perform maintenance or correct problems with the computer system. And some can help computer systems run better and longer without problems. Really what I think of are two different things. Your antivirus programs, of course, that keeps your computer safe and virus free. So that's one of those things I think of. The other that I often think of is when your computer starts to slow down and as you listen to it, it kind of chirps. Okay, the drive is becoming fragmented. I don't have a good picture of this fragmentation. I should grab one, but there should be one of your projects should talk about defragmentation. So what essentially happens is a computer will copy information onto a drive, and remember that drive is spinning, but it will essentially copy information onto a drive in a contiguous way. 1, 2, 3, the sectors right next to each other. That way when it spins, the read-write head can pick up the information very quickly. What happens after time and files have been placed all over that drive, you may save a file that is located all over the drive. There may be one here, a part of one file here, a part of the same file here, a part of that very same file over here. So that read-write head and the hard drive has to spin a lot and move around a lot in order to be able to just pull that same information. So that's called fragmentation. Now what a defragmenter does, it picks up those spots here and here, moves the information from here over, and then puts those two spots back together, so it puts the files back together again, so it runs more quickly. So that's an example that I often think of with utility programs. The next thing that we'll talk about is proprietary software and off-the-shelf software. So proprietary software is one-of-a-kind program for a specific application, and usually owned by a single company. Think of Apple. Most of Apple's software is proprietary. They own it, they work with it, they do their stuff. Now, off-the-shelf software is kind of like Microsoft Office when you buy it. It's less customized. You can customize it maybe to some extent, but it's something you just buy off the shelf. So remember, proprietary versus off the shelf. You know, yes, I can say that. Proprietary is like the Apple software, but it is, I need to probably restate that. Proprietary is one-of-a-kind program for a specific application. Okay, that's fine. It's usually made by one company. Think of your Mac OS. Think of Mac applications. Now that can also be off the shelf. So let me restate that. That can be off the shelf as well. Now, your Microsoft software, I was off on a tangent. Your Microsoft software, Microsoft Office is proprietary as well. Okay, and you can buy that off the shelf. Now you can also customize software. Certain software like open source software you can customize. The Linux operating system, other open source software is like LibreOffice, where you can actually grab the code and change it and work with it. So you have proprietary here versus what we might see as off the shelf. Okay, now I hope that cleared that up a little bit. My apologies for leading you astray. Next slide. Personal application software. I'm trying to get through this to save just a little bit of time for a really cool cloud video. Okay, so overview of application software. There is software as a service, which allows businesses to subscribe to web-delivered business application software by paying a monthly service charge or a per-use fee. And you see that individually too. You see that individually with, if you want to get a big, let's see, a better example than Dropbox. It's essentially a file service, but it is an application nonetheless. And can reduce expenses by sharing the next bulleted item, can reduce expenses by sharing its running applications among many businesses. Okay, now, a little bit about cloud computing. Use of computing resources on the internet rather than on local computers. I've got a video for that, and I'll go ahead and turn that on in just a second. So we have mobile application software that one of your projects talks about or researches. Work group application software supports teamwork, sort of like the groupware, and even OneNote is an example of groupware. And then the enterprise application software, which is a set of integrated programs that manages a company's vital business operations. So an example might be the software that actually runs the student information system. Okay, because there's an HR component, there's a financial aid component, there's a student registration system. So that's an example of enterprise application software. And it's also sort of an ERP sort of picture. So enterprise resource planning picture. Now with this said, I'm going to go to this cloud computing video. It's about 5 minutes in length. And it is right over here. I'm going to first mute my computer and run this.
Cloud computing is all the hype right now. But what does it really mean? Do you have to be sitting on a mountain with a computer among the clouds? Or on a plane with a laptop? Does it work when it's sunny? Can you actually type on a cloud computing keyboard? Cloud computing is pretty big, and it's growing bigger every day. There are basically 3 layers to cloud computing. Companies use them differently based on what they offer. At the bottom is the foundation, the infrastructure. This is where things start and where people begin to build. This is the layer where cloud hosting lives. So let's talk about hosting in the cloud, which is an older concept that, due to technology advances, is finally starting to work really well. Let's say you are a company and you have a website. And the website has a lot of short conversations that are exchanged between members. You start with a few users talking to each other, and they start telling their friends about your site. And they tell their friends, and their friends tell their friends, and so on. You are successful. But with success can come problems. Your equipment just can't keep up with the demand. Your service slows down, and suddenly you are in trouble. A few years ago, you would have put your website on a computer or server somewhere. And when your success kicked in, you had to run around and buy or rent new servers, set them up, or have someone set them up for you. Hundreds of thousands of companies do this now. It costs a lot of money and it takes lots of time. This is called hosting. It takes time to set them up, and they cost quite a bit of money to keep running all the time. You pay for these servers when you are using them, and you pay for them when you are not using them. You really just want to build your service and improve your product. But instead of success, your customers are getting angry, and your successful business is shrinking away. Now you have a better option, cloud computing. With cloud computing, you have access to computing power instantly when you need it. Put your website on a cloud server just like you would put it on a dedicated server. And when people start visiting your site, if you suddenly need more computing power dedicated to your website, you can scale up as much as you need almost instantly. You get your computing power as you need it from the cloud, on demand, and your customers stay happy without noticing any difference. And if your traffic dips back down, you can release your servers back into the cloud just as easily. This is a major advantage, so I'll say it again. When you need more computing power, you can get it instantly from the cloud. And when you're done with it, you release it back to the cloud. Billing is easy too. It works the same way you pay for gas or electricity. When you turn on a light, the meter starts running and you are billed for the electrical power that you take from the power grid. And when you're done with the light, you turn it off and the meter stops running. Or you can think of it like getting a taxi. The meter runs when you ride, it runs much slower when you stop, and when you're done with your ride, you get out and you pay your fare. Why buy the whole taxi when you can just pay for the trip? But wait, how do you actually work with the cloud? You can't physically touch your hardware. Easy, using your own personal computer. You remotely access your cloud server and control it. You can put whatever you need on it, website or software or code, whatever, and then just disconnect it when you are done. You never actually touch it physically. The key with cloud computing is not to focus on the hardware. You just focus on your website or your software or code or whatever it is you're doing. Think of it like you would any cloud service. Do you really care where, on what physical server your email is hosted? Isn't it vastly more important how the service works and that it's reliable and stable and easy to use? Here are 3 reasons why cloud hosting is becoming so popular. 1. Scalability. It's easy to grow or shrink to match your demand. If you need 1, 2, or 10 servers, with cloud hosting you can easily grow or shrink the number based on what you need right now. 2. Cloud hosting is instant. The computing power is there when you need it. You just turn it on. Whatever you need is instantly available in the cloud. And when your need goes down, you can simply turn them off. 3. Save money. You only pay for what you use and not for having equipment sit around just in case you might need it. With cloud hosting, you can stop worrying about your hardware. You can work on building your business instead. Using cloud hosting will save you time and money, and it's there for you to use instantly. So dump those old servers and head to the clouds. This has been Cloud Computing by Tim and Michael at GoGrid.
Okay, I'll turn on the audio again. So I really like that video. That's pretty cute. Back to my PowerPoint. Okay, so finally, it was so non-technical, but explained the technical stuff really well. So that was great. Finally, this talks about copyright and licensing. So most software products are protected by law using copyright or licensing, and I'm running out of time on my 15-minute segments, so I'll go ahead and leave it at that. Part 3 then covered, we covered network operating systems, enterprise operating systems, utility programs, proprietary and off-the-shelf software, and then also something about the software as a service and cloud computing. So thank you very much.